Here's a project from Wood Magazine, cut almost entirely on the table saw. Attention to the initial setup and maintenance of this saw allowed for the cutting and joinery of all these small parts to come together perfectly. So here's a top-down review of what it takes to get this saw to provide the quality you demand. The heart of any table saw is the table saw blade, and it's asked to do two things, both rip and cross-cut. In a ripping operation, the cut is made along the grain of the wood, and the shavings that come from that are a little bit strandier. It's the toughest thing for a saw to do. The blade that you'll use with that needs slightly larger gullets and fewer teeth and a slightly more aggressive tooth angle. In a cross-cut operation, the wood is cut across the grain of the wood and the shavings and sawdust are more granular. In that case, you'll find that the blade that you can use will have more teeth spaced closer together. The table saw blades normally for those will have 60 to 80 teeth. Now, if you're asking the saw blade to cut both rip and cross cuts, that's called a combination blade. And what you'll generally find there is a blend of both multiple teeth and gullet width. And those blade counts are normally in the 40 to 50 range. So let's talk about the grind of a table saw blade tooth. A flat grind allows for the blade to come straight on into the cut. And it's mainly used on ripping blades, and it keeps that cut in line even though the grain may be trying to move it offline. And then there's an ATB grind. In an ATB grind, the blade is cut to allow the initial cut to start at the tip of the blade and then taper to the back. It provides a much cleaner cut, and it's normally used on combination blades and on cross-cut blades. And you'll see that type of cut right here. One of the first ways to ensure that a board doesn't get pinched when ripping it is to align the blade to the table. And one of the ways we do that is using the miter gauge slot. The miter slot is a fixed reference point on the table, and we can use that to align the blade. Now, it's a fairly easy process to do. All we're going to use is a combination square. And adjusting the nose or the blade of that combination square, I'm going to slide it over till it just touches a blade tooth and lock it in. And using that same tooth and sliding that from the front to the back, check to see whether or not the offset between the edge of that blade and the tooth is the same. If it's the same, there's really no adjustment. But if you find that it's binding, or if there's a large gap between the front and the back, it's time to adjust that blade in relation to the table. And it depends on what type of saw you have, whether it's a contractor or a cabinet saw. And I'll show you how to do that. This is a cabinet saw, and in this case, the blade mechanism is bolted directly to the base. So all we're going to do is loosen the bolts around the base and shift the top. So you'll find a bolt in each corner. You'll want to loosen 3 of those bolts pretty well and leave the other one fairly snug. You need as a pivot. So then we'll align the tabletop, check our blade, and keep aligning until we've got it the way we want it, then retighten the bolts. Now, the suggestion would be that after you get done doing that, again, check that blade with your compound square. If you find that tightening those move the table a little bit, you'll have to repeat the process. But generally, once it's done and they're snugged up, you should be good to go. Now, in a contractor saw, the trunnions are held to the table with 4 bolts, and those are positioned here and here on the underside of the table. So to be able to loosen those, we're going to have to get up underneath that table and loosen those bolts. It's not a lot of fun. Fortunately, it doesn't happen terribly often, but doing that will allow you to make the adjustments. Now, you don't have to lay the saw on its side like we've done here. Actually, you'll be lying on the floor trying to reach up inside your cabinet. But it made it easy to show you where the trunnion bolts are. Here's one here, there's one here, and then there's one on either side at the top and bottom. Loosening 3 of those fully and one just a little bit allows for a pivot. That makes it much easier to make the adjustment. Now that those bolts are loosened, the idea is I'm going to use this dowel to just gently tap the top of the trunnions. That will allow this saw blade to move. When I'm pretty comfortable, I've got it close, I'll go back in with my combination square, check that setting, and when I'm happy with it, retighten those bolts. But again, I'll want to go back and check that a second time, because sometimes after you tighten the bolts, you'll find that the blade moved just a bit. Again, this doesn't happen often, and it's relatively rare, but it's a nice thing to be able to adjust that saw and find out that from now on it's going to cut perfectly. The next adjustment at the top of the table is making sure that your fence is parallel to the miter gauge slot. This is the second adjustment that kind of helps keep some of that pinching and burning issues at bay. So what we'll do here is using the same combination square, I'm going to start at the front edge of the fence and make sure it touches nicely at the edge of that front edge, and then slide my combination square to the top. And I'm checking just to make sure that the offset at this end of the fence is the same as it is at this end of the fence. If they're equal, your fence is square. Now there are some discussions here about whether or not the back of the fence should be set just a little bit further away. And you can make your choice there. If you are going to set it away, about 1/1000 of an inch, give or take the thickness of a dollar bill, will provide enough clearance in the back to give you that slight offset in the back of the fence. To make those adjustments, this particular fence has 4 bolts here. They'd be loosened and you can make your adjustments there. All fences are a little bit different. It's a good idea here to check with your manual and find out how to do your fence. But that's the second adjustment. It's pretty easy to make, and you'll occasionally be checking that to make sure it doesn't come out of square. Now the last adjustment that I'd like you to make is assuring that your riving knife or your splitter sits directly behind the saw blade. In this case, I'll just use a straight edge. I want to lay it up against the teeth, not the blade body in this case, but up against the teeth, and check the alignment of that next to this riving knife on one side and on the other. The idea is as a board goes through there, it needs enough clearance to clear that riving knife or splitter. And just to take a second, please make sure that you're using a riving knife and splitter on your table saw. A lot of people remove those. It's one of the biggest causes of injury is kickbacks. A riving knife or a splitter will all but eliminate that possibility. Now, as long as we've got the blade up, it's time to check and make sure that that blade is 90 degrees to the table. And we'll set the 90 and the 45-degree stops in doing that. The first thing you'll need is some scrap. 3-inch wide pieces, one about 8 inches long and the other is about 1 foot long will help. And a small plastic triangle like this. They're fairly inexpensive and they work really well. So the first thing, and I've already done it, is crank the saw blade up to 90 degrees, at least that it's set there, and lock down that setting knob. And set my triangle against the blade body. Now not the teeth this time, but against the body, and just visually sight that edge. And if it's nice and lined up, you're perfect. There's no real adjustments to make. But if you find out that the blade is tilted to a slight angle, you're going to have to make an adjustment in the side of the saw, and we'll show you how to do that in a second. So the first thing is, I've got this adjusted pretty well. It looks like it's at perfect 90. And one of the ways to check that is using a small block of wood. What we're going to do is run that piece of wood through, standing straight up, cut the piece of wood, and then flip one end over and then slide them back together and see how that 90-degree works. Okay, now taking this piece and flipping it end for end and line up those pieces, it's a clean line at that joint, and you can tell what you've got now is a perfectly set saw blade at 90 degrees. Now after you've checked the 90 degree, it's time to check the 45. And again, we'll use the opposite side of this plastic triangle and against the body of the blade, not the teeth, and slide that up and check the alignment. Now again, this looks pretty good. So the way to check that is, I've got 4 pieces of stock. These are 3 inches by about 12 inches. Most important part is making sure the outside edges are parallel. And what I'm going to do is cut 4 edges, cut the miter on each of these sides, put a stop block on here, and then cut the opposite sides. Once I put them all together to form a box, we can check the offset of each one of those joints and find out whether or not we're actually set at 45. So here's how it goes. And now that I've laid a little tape out on these and pressed against the corners, that joint is actually pretty good. Now the band clamp on here, it's perfect. It's just kind of hard to get a grip on it, but that did a really nice job. Now, if any of those joints were really out of line, or your 90-degree joints were out of line, it's a way of making those adjustments underneath the saw that will set that 90 and 45-degree stop, and from there on then you'll be perfect forever. Let me show you how that's done. Okay, now to make the adjustments on this particular cabinet saw, they're made underneath the saw and actually through this small little side door. And the upper screw, that's the stop for 90 degrees. The lower screw is the stop for 45, and the adjustments are made there to assure that the 90 and 45 that you set on top of the saw is adjusted and fixed at the bottom. Now, we'll normally suggest that when you make that adjustment, it's nice to go back, take it off that adjustment and bring it back up to it to make sure that the adjustment you made mimics what you decided to do on the top of the saw. Now that we've gotten the table saw blade adjusted at 90 and 45, it's time to do the same thing with the miter gauge. What we're going to do is the same type of setup we did initially, and what I'm going to use for the pieces are 5-inch piece of material and 4 pieces of 3-inch material, about a foot long or so. And again, using that same plastic triangle. We're going to set the plastic triangle up against the table saw blade, and again, making sure that we're touching just the blade body and not the teeth, and slide the miter gauge up and see whether or not it aligns. In this case, we've got a pretty good alignment, but any adjustments can be made now that we know that the blade is square to that miter gauge. So the first part of this is take a 5-inch piece of material. We're going to cut straight through, and we're going to flip those pieces end for end and see whether or not they line up. That will tell me whether or not my miter gauge is actually set at 90 degrees. Start with one edge. This is how they started. We'll flip them end for end and see how these pieces line up. And there is a really pretty adjustment. My miter gauge is set at exactly 90 degrees. So now that we know that the 90 degree works well, I want to check the 45. So I'm going to spin the miter gauge around to the predetermined stop and see how close we are. And do the same thing when I cut these 3 by 12-inch pieces as we did with the table saw blade set at 45. We'll cut the 4 edges, flip them over with a stop block and cut the other 4, then tape them up and kind of check the joints. Okay, now you'll see in this spot where that predetermined stop is not right. Now the idea is to adjust that fixed stop. Originally I thought it looked like it was pretty good, but actually it's off just a bit. So what I would do now is readjust, make a few more cuts and repiece. Once I find that all those miters fit together, I can make a permanent adjustment that puts that miter gauge back at 45 every time. There's always a lot of discussion about where to set the blade height when you're cutting material. I generally like to take the stock of that material, lay it up against the blade, and make sure I can just see the bottom of the gullet. Another discussion is, or another feeling is, making sure that blade is about 1/4 of an inch above the work surface. Both of those seem to work. The idea here is to maximize the amount of cut that you're getting, a lot of downward pressure, without increasing the danger of that blade should you make contact with it. I don't like a blade that sits down very close to the face here, that just clears, because there's an awful lot more forward cutting as opposed to downward cutting. So however it is you look at it, my particular feeling is that the gullet should just about show, which exposes about 1/4 of an inch of that blade above the cut. You get a nice clean downward cut, very little chip out when you do it that way. Most table saws come with a relatively small miter gauge. This relatively small back makes it hard to stabilize material. I think it's a really good idea to build some kind of an auxiliary fence for the back side of it. You can make these out of MDF or multi-ply plywood. They can be attached to this miter gauge with double stick tape or screwed through the front. I prefer to do it with a T-slot. I cut that with a router bit and then use a couple of toilet bowl bolts to fasten it. So it slides over the back here. It's easily adjustable. It allows me to use this in a variety of ways. The nice part about an extension is it backs up the cuts. It provides a really nice clean cut on the backside edge, kind of like a zero clearance. And actually, and I'll show you in a second, how you can use it to lay out each cut without having to slide your board up next to the wood. What I'll do is slide this over the blade, make one quick cut across the front of it, and the kerf that it leads provides a perfect spot to be able to lay out your cuts time and time again. So now you've got a kerf line across the front. It allows me, if I'm planning on cutting material, to slide my hash mark right up against that kerf line, and I know exactly where the cut's going to go. We can also use this with a series of stop blocks. Either create an additional piece of wood all the same length, or if you've got a mitered end like this, you can trap a 45-degree miter or a 30-degree miter. It's a great idea, works really well, easy to make, and I'd make a few of them and have them on hand all the time. If you look a little closer at the top of this table saw, you're going to see what's called a zero clearance insert. The reason it's in here is to make it a little bit easier to support a cut so that when you've made the cut with the table saw blade, it doesn't chip out the bottom. Most of the inserts that come with your saws have a much larger opening in the area right here. It allows for a table saw blade to turn from 90 degrees to 45 without contacting the plate, but the area underneath is so wide, it doesn't really lend any support. So you can buy as an aftermarket or from the manufacturer zero clearance inserts, or you can make them yourself. And I kind of like to make them myself. You can make them out of MDF, you can make them out of multi-ply plywood. I've even made them out of the ultra-high molecular weight, that white material you normally see on table saws. The way to do it is pretty simple. I take the insert that comes from the saw and use this as my template. I'll rough cut template material to match the length and width of the piece that I've got, and then using a pencil, just scribe the radius around the edges. Now, once you've got this radius laid out, you can take it to a bandsaw and use a disc sander to clean up the edges. Or you can take a bandsaw and rough cut the edges and follow it up with this flush trim bit on the router table. This will follow your existing throat guide all the way around the outside and create an identical piece to match this. So the last thing we want to do is make this plate level with the surface of the table. So we'll take our insert plate. This will show me the location of the holes. Drill 4 small holes and put an Allen set screw in those openings, and then use that to adjust the level on each one of these. Now, one of the issues is if I try and lay this right in the saw, it's too thick to fit in that saw without the saw blade contacting it. So what I'll normally do is I will swap out my 10-inch blade for an 8-inch dado blade. Diameter is a little bit smaller. Put the blade all the way down in the saw, slide my zero clearance into the top, and to make that cut, I will slide the fence over the top of that. Of course, not far enough to be cut by the blade, and slowly raise that table saw blade till it cuts the kerf. You'll need to make a few of these. You'll wind up using them. You'll be glad you did.